Hello everyone, my name is Lakshya and today in this video I will be discussing about the QUIC protocol. QUIC is a modern internet transfer protocol that is changing how data moves across networks, and in this presentation I will be covering what QUIC is, why we need it, how it works and where it is used, about its future and risk associated with it. So let's get started with what is QUIC. So if you look at what is QUIC, QUIC stands for Quick UDP Internet Connections. It was developed by Google and is now standardized as RFC 9000. Basically, it runs on top of UDP but brings in the reliability of TCP. And unlike traditional TCPs, Quick combines the transport layer handshake with encryption in one step, which reduces the timing and making connections much faster. It operates at the application layer but still provides transport layer services, making it a big innovation in internet communications. And why we need QUIC. Traditional TCP has some issues. It has some limitations like head of line blocking and slow collection setup. And if I talk about what is head of line blocking, basically it's a packet delays. When one packet holds and it makes hold the line of packets on delays, that is commonly known as head of line blocking, and which slows the connection setup. Basically, these create delays, especially in modern applications that need like high speed and low latency. Like for mobile devices, switching between Wi-Fi and mobile networks often breaks connections with older protocols, but QUIC solve this with smooth connection migration. And security is also better because QUIC has TLS 1.3 built in, which is built in, not like additionals. So encryption is automatic from the start. Now, if I move next, so now we're going to talk about its frame structure and functionality. So QUIC is built using a frame-based structure. There are different types of frames that handle data efficiently, and stream frames carry application data, remove head-of-line blocking, AC key frames, which is basically acknowledgement, confirm which data has been received and help with recovery, and other frames handle connection control, flow management, and congestion control using things like ping, reset, or max data. And this makes QUIC both flexible and efficient as well as compared to TCP. So now in the next slide, we're gonna compare QUIC with traditional protocols, TCP, TLS, HTTP, on the basis of these features: handshake, head-of-line blocking, connection migration, and built-in encryption multiplexing. So here we can compare QUIC with TCP, TLS, HTTP. Like with TCP or HTTP, the handshake takes 2 to 3 round trips, and with QUIC, it only takes 0 to 1, which basically reduces the timings. And QUIC also supports connections migration, built-in encryption, and multiplexing, which TCP does not. And the main advantage is that QUIC reduces latency and makes mobile performance smoother as compared to other protocols. And the key advantage is zero RTT resumption. So as I just said, its handshake can be 0 to 1 RTT. That is because whenever there is some history saved of a connection, basically whenever there is some previous connection, so there is no need to make a single RTT handshake as well. It can start with direct transferring of data if it has the connection in his cache. Now, if I talk about applications which are using QUIC, QUIC is like already used widely. Google uses it in YouTube, Gmail, Google Search, Google Cloud, with like more than 95% of traffic running on QUIC. And if I talk about social media platforms like Facebook, Instagram, even I used Facebook for QUIC capturing in Wireshark. And Facebook and Instagram use it to deliver content faster especially for mobile users. And content delivery networks like Cloudflare Fastly also support QUIC to make websites load faster globally. Basically, it is very fast as compared to traditional protocols. Now we will discuss about security considerations. QUIC has many advantages. It requires TLS 1.3 encryption, hides connection IDs, reduces attack surfaces, and provides forward secrecy. But there are still some risks. QUIC can be used in DDoS amplifications attacks, and it may be fingerprinted by attackers, and it can sometimes bypass traditional network security devices. So while it is very secure, monitoring is still important in QUIC. And as we know, DDoS is distributed denial of services. Now, now we will talk about the scalability analysis. QUIC is highly scalable. It reduces bandwidth used by around 40% thanks to header compression and multiplexing. And it allows servers to handle twice as many connections because it manages connection states more efficiently. And latency can be reduced by up to 60% with zero RTT resumption and connection migrations. And this makes QUIC great for environments like with lots of users and high demand. That is why like Google and content deliver platforms use QUIC. Now, if I discuss about implementation challenges, like even though QUIC is powerful, it comes with challenges, and many firewalls and middle boxes don't handle UDP properly. So network setups may need updating. QUIC runs in user space and uses encryption heavily, so it can increase CPU usage compared to TCP. Also, like traditional monitoring tools need upgrades to fully understand QUIC traffic, and so while QUIC has benefits, its deployment requires careful planning. So we should be like careful about its implementations. Now, if I talk about its future, the future of QUIC looks very strong because it's the foundation of HTTP 3, which is already being adopted by major browsers and servers. It is also a good fit for IoT devices that switch networks often. And as enterprises update their systems and tools, we will see QUIC being used more and more in internal and business applications. Overall, QUIC is like designed for the modern, mobile first, and security focused environment. Basically, we can say QUIC is a protocol of modern world where devices are connected and the delivery of the content is very fast and security focused. That is all about QUIC, and thank you for watching my presentation on QUIC. I hope this helped you understand like what QUIC is, why it's important, and how it's shaping the future of the internet. So now I'm gonna show the packet capturing, which is I have saved from www.facebook.com. Now, so here's a Wireshark filtered with QUIC protocol. And if we expand the first packet, here we can see it's QUIC initial packet sent over UDP port 443. Inside it, we can see. So here we have information about QUIC. Here we can see the connection ID, and if we expand, so this information is about QUIC, and this is the source connection ID, which QUIC uses to support connection migration and stream frames, which allow like multiple streams of data without blocking each other. And if we see about the payload of QUIC, it appears as encrypted application data. That is because like QUIC enforces encryption by default. And if I compare to TCP and TLS, QUIC removes three-way handshake and the separate TLS handshake. This reduces round trips and improve latency. It also solves head of line blocking issues that HTTP over TCP used to face. Now, if we expand, mm, yes, so here we can see it uses TLS version 1.3 handshake protocol, and there's a lot more information here about it. This is server hello message, and if I go for basically this capture shows how QUIC carries TLS 1.3 inside its own packets and combining handshake and encryption into one step. We also saw like how QUIC uses UDP port 443, supports fast initial connections and avoids head of line blocking by handling multiple streams independently. Overall, QUIC is designed to make the web faster, more secure, and more reliable, and Wireshark helps us clearly see these improvements in action. Thank you so much for watching for my video. Hope you understand QUIC in a very good manner.